Hey everyone, in this Back to the Basics tutorial, we're going to be exploring arrays and vectors in C++. So not really necessarily vectors is a common practice among programming languages and basic concepts, but arrays definitely are. And vectors is just one of those things that you learn with C++. So just to reiterate, the whole goal behind these Back to the Basics tutorials is to kind of give new developers or new computer science students kind of an edge up, so that way they can see in repetition different ways to interact with what they're learning about. Because sometimes in class it's not always enough to see one or two examples. It's always nice to see a few more. So again, this topic is going to be focused around arrays. So you'll notice that I do have my project open. I am using Visual Studio Code. I have already configured Visual Studio Code. If you want to use Visual Studio Code rather than some other IDE, I do have another tutorial on the configuration process, but it is outside of the scope of this particular tutorial for C++. So I do have my C++ file. This is where we're going to add all of our code. We're going to start with some basic array examples and move our way into vectors. So first what I'm going to do is I'm going to create in a basic array. So I'm going to say int, I'm going to call this values, and this array in particular is going to have 4 values. So it's going to have a size of 4. So let's go ahead and add some values to this array. So first off, we're going to say values, and then we're going to say at the index of 0, because arrays in C++ and actually I think most programming languages, they do start at 0. We're going to say the first integer value is going to be 2. We're going to say that the index, so the value at index 1 is going to be 4. The value at index 2 is going to be 6. And then finally, the value at index 3 is going to be 8. And you'll notice that I've stopped at 3 because we do have 4 different values, hence the value of 4 that we assigned when we created this values integer array. Now, if we wanted to access any of these values that we set, we can just do simple cout statements. So we can say cout, we can say values 0 if we wanted to print out the value at index 0. And then likewise, if we wanted to do the same for each of the following. And you'll notice that I just copied the line 3 more times. I'm going to change the indexes, and we're just going to run it and see what it looks like. So I'm going to say run. And you'll notice that it did print out everything that we anticipated. So nothing too complicated as of now. We've just defined an array, we've added our values, and we've printed them out. Now if I tried to add an element, so if I tried to say something like add another one that says index 4, it might work. In many programming languages, you'll get an out of bounds exception because you've now tried to set data that doesn't really exist. So, but in C++, it won't necessarily throw an error. It'll just crash if that particular piece of memory becomes required by another part of the program. So this is our most basic example. We're going to change it up a bit. We're going to say, well, what if we wanted to kind of shorthand this? What if we don't want to kind of spell it out line by line? We want to set the value of the array as we declare it. We can definitely do that. So instead of saying 4, I can say something like this. I can say 2, 4, 6, 8, and so on and so forth. I can set as many values as I want here, and it'll save me from having to do lines 7 through 10. So if I were to save it, and if I were to run it, I should get the same results. And I did. So it printed out values 2, 4, 6, and 8. If I wanted to, I can add 10. I can choose whether or not I want to print it out or not. In this case, I'm not printing it out. So it still says 2, 4, 6, and 8. So when it comes to setting arrays like this, the standard way, without using the new operator, the memory is handled automatically. So when the array is done, it's deallocated automatically. We can't change the size of the array after we set it. We could only use it and set values within that array. So what if we wanted to first say, you know what, we have 5, let's go ahead and stick with the 4 example. Let's say we have four values at the start, but as we progress, we decide, you know what, we want 10 more values to end up in this array. We can't just start adding them because we can't easily change the size of the array in C++. In other languages, it's a lot easier to do this, but in C++, it's a little different. So what we could do is we could actually copy our array into a larger array. So what we're essentially doing is we're setting another array with the larger size, and we're copying our old array into it. So let's give it a shot. I'm going to delete this, and I'm going to say something like int, and I'm going to say dest for destination, and I'm going to say that this has a size of 10. We're also going to, for clarity reasons, we're going to change the name of this from values to source to represent our source array. So we're going to copy source into destination. And in C++, using our namespace std, what we can do is we can say copy, and we can say our source, and we're going to say we're going to copy it. The size is going to be the source, so it's going to be 10, and we're going to copy it into the destination. So that would be our copy command. Now, if we wanted to, we can check the size of both of these arrays. So let's go ahead and in a previous example, I believe I demonstrated calculating size of an array, but we're going to do it again. What we can do is we can make use of the size of. So we're going to say int. We're going to call this maybe source size, so s size. We're going to say size of, and we're going to say source. But we can't necessarily leave it at that because that size of will give us 16 because it assumes that the max value of each one of our elements is going to be 4 bytes. So 4 times 4 is 16. But in reality, we want the length, not the actual maximum size. And we can actually find that by dividing. So we can say size of, and we can say source. We're also going to calculate the size of the destination. So we're going to say int, we'll call it d size for destination size. Size of, we'll say dest, and then divided by size of dest, so with the pointer in front. And like I demonstrated in the previous tutorial, we could also say dest and then the first element of that array as well, or any element for that matter. But we're just going to use the pointer. So we have the sizes. Let's go ahead and print them out to see what our sizes look like. So we're going to say cout, we're going to say s size, we're going to separate them by slashes, and we're going to say d size. So let's figure out what we got first before we look at our array that was copied. So I'm going to run it. So our source array is 4 characters in length. Our destination array is 10, not 10 characters, but 10 values in length. And now what we want to do is we kind of just want to see what our destination has now. And what that looks like. So let's go ahead and do a loop. And I did do another tutorial on loops. We explored plenty of loops in that example. Definitely look at that video if you're stuck on loops. But we're going to say for int I equals 0, I less than, then we're going to use d size, so the destination size, and we're going to increase that loop by 1 every iteration. And we're just going to say cout destination I, so whatever the current I loop value is going to represent our array index, and then we're going to say end L. So let's go ahead and try to run it, see what we get. I'll scroll up a bit. So what it did was it printed out 10 potential values. So we have 2, 4, 6, and 8. Which would be the values that we've copied over, and then there isn't any data that follows it because we haven't filled that yet. So if I wanted to, we copied our array over. Let's go ahead and before we start our loop, let's go ahead and say, well, we know we copied 4 of them over, so we're going to say destination, and we're going to say the 4th element, which has not been set yet, and we're going to say that equals, let's go ahead and say 10. We're going to save it. We're going to run it. And it is there now. So, I mean, we do have the space allocated for more values in the array. And in some programming languages, if it's not set, it might be 0. In this case with C++, it's just printing out some semi-random numbers here. It has to do with the memory allocations of those particular points, but it'll vary. So again, like I said, when it comes to setting an array like this, even though that we've declared 2 arrays now, after this one's done, it's just going to be automatically deallocated, so that way memory is freed up in your C++ application. But we're going to explore another way now, and this way it actually deals with pointers, and it has to do with now we have to now manually deallocate our arrays. So this is going to be another way for working with arrays. So I'm going to erase this. If you wanted to go back and see what I did, just rewind this video to get more information. But let's go ahead and wipe this out. This is, again, more arrays. We're not quite in the vector space yet, but we're going to do another approach for arrays. So this time around, I'm going to say int, but I'm going to say values as a pointer. And I'm going to say equals new. I'm going to use the new operator. And I'm going to say int, and I'm going to give it a size of 4. You'll notice that after we've done this, we can proceed pretty much as normal with our arrays. So we're going to say values, and we're going to say maybe 0 equals 2, values 1 equals 4, values 2 equals 6, and then values, let's say, 3 equals 8. Let's go ahead and print this out to see where we stand. So we're going to say 4 int I equals 0, I less than 4, and then I plus plus. You'll notice that I didn't get the size of this array. I could have, but you know what? It's just going to be easier for us to just put that size in ourselves right now. And we did less than 4 because it starts at index 0, and we don't want any kind of out of bounds errors. So we have our loop. Let's go ahead and say cout. We're going to say values I, and then we're going to do a new line between each print. Let's go ahead and run it. And 2, 4, 6, 8. So life is good so far. So like I said though, between this way of declaring our array versus the other one, we use the new operator. We have to manually deallocate our array to free up memory if we want to. Otherwise, this is going to exist for as long as our application is running. So if we wanted to, we could deallocate that array by doing the following. We could use delete. And because this is an array, we use the array brackets, and we're going to say values. And you'll notice I did it above the loop because we're going to see what happens when we try to print out the loop as of now. So we're going to say run. And you'll notice that it still prints out. And the reason for this is because just because you've called delete doesn't mean that your application has freed up that memory immediately, because it may not be necessary. It just says that, you know what, we no longer need this data. So if something takes priority in our application, it could go ahead and use that point in memory. So this is arrays, and the reason why you may not want to use just standard arrays in C++ is because of how it handles sizing of your arrays. So you'll notice that in order to resize our arrays, we had to copy. That's not necessarily that great. Instead, we could use vectors. So vectors allow us to add elements to a vector. We could use several of the very powerful functions that it offers. Also treat it as an array like we would here. So same kind of commands. But again, it handles more of the memory allocation stuff for you. So let's go ahead and work with that. We're going to include another line. Instead of just IOStream, we're going to say include. We're going to say vector. And just to kind of give some warning here, I am by no means a C++ expert. I spend most of my time in other programming languages, so things are a little different between those programming languages. But the concepts of arrays, not necessarily vectors, the concept of arrays carries across all programming languages. It's just with C++, it's very strict in how it handles things. So definitely continue to do your homework on this stuff, but at least know that what we're kind of showing here on the screen is handled across the languages as general practice. So let's go ahead and wipe this out. We included the vector at the top. Let's go ahead and wipe out what we have this so far. we're going to look at a vector example. So we're going to try to accomplish what we accomplished at the very beginning, but this time using vectors. So we're going to say vector. We need to specify what type of vector it is. So in this case, like what kind of array it would be. In this case, we're going to say it's going to be int, and we're going to say values. Now, if we wanted to, we could do the following, and I'm going to show you multiple ways of doing this, but we're going to say values, and we're going to add an item to this vector. So we're going to push it to the back. So we're going to say push back, and we're going to say 2. So 2 is added to the end of this vector. So if we were to loop through this right now, it'd only say 2. I'm going to push back another one. So I'm going to say push back 4. So if I were to loop through this and print it all out, it would say 2 and then 4. But you'll notice that I've never declared an actual size of this vector as of now. So that's a pretty cool thing. I'm going to say values push back 6 and values push back 8. So I've added four values to this vector. Didn't specify a size. Even used a different kind of function command for adding it. If I wanted to loop through it, I can say 4. I can say int I equals 0. I less than, and this is where it gets a little different. So you notice that we did the size of when we calculated the size of our array. Vectors already has a function for us that gets the size of our vector. So we're going to say values.size, and this function will return the actual length of our vector to make life a little easier. So we're going to say I++. So again, this kind of adds on to vectors being easier and probably the preferred way when using C++. But we're going to say cout I. We're just going to print out the index, and we're going to print out the actual value at that index. So kind of just like what we saw in actual arrays. So I'm going to run this. So I'm going to say run. And it printed out the index of that particular vector as well as the value at that particular index. So very much in an array fashion. So let's look at another example. In this example, we're gonna make use of a few more abilities that vectors have to offer. So in this case, we're going to check to see if a vector has any values at all in it, and potentially even erase all of those values as well manually. So let's go ahead and leave our values vector, and we're going to say the following. So we're going to say values. We're going to say push back. I'm just going to add a random integer value here. It's going to be 44. So our vector does have data in it right now, but we're going to do a check. We're going to say if values dot empty. So we're going to say so the empty function actually returns a Boolean, so it's going to return true or false. So if values has nothing in it, it will return true. But we want to check to see if it does have values in it. So we're going to say if it's not empty. So if empty is false. If it's not empty, we're going to say values.clear. So we're going to empty it out. And then we're going to add 2 more values to it. So we're going to say values.push back. I'm going to say 2. Values.push back 4. And these values that I'm pushing into these vectors, they're meaningless. They're just random numbers that I'm picking out of my head. So don't think that 2 and 4, because I've used them consistently, have anything important to say. It's not. So I pushed 2 in, and now I'm going to loop through this. So I'm going to say for int I equals 0. I'm going to say I is less than values size. Remember, size is the length of this vector. And I'm going to say I++. And I'm going to say cout I, and I'm going to say I'm going to separate the index, and I'm going to print out the values. This time around, instead of saying I like that, like I did in the previous example, I'm going to use another option that I can with vectors. I'm going to say values.at. So it'll do the same thing, at I, so that particular index. So I'm just showing an alternative of what you can do. I'm going to run it. I'm going to say run. And this time around, it only said 2 and 4. So in this case, I'm going to change it up. So I'm going to say if values is if it's empty, if it's true, which in this case we know that it's not empty, it's going to skip this. So it's not going to run the clear because right now we're going to say only if it's true, only if it's empty, we're going to clear it again, which is kind of meaningless. It's pointless. I'm just going to show you that, hey, values 44 is still there. So I'm going to run it, and it's still there at index 0. So you can see the power of these functions, and you can see that I was able to I was able to remove this item, and the vector automatically resized for me. So I was able to add more values in it. The size right here actually changed along with whatever our vector is holding, which makes it a lot easier than working with standard arrays in C++. So let's look at another example. Let's look at an example where maybe we want to insert a value somewhere within our vector. So as of right now, we've only pushed values to the back of the vector, so adding it to the end. But what if I wanted to insert one in the middle? So we're going to make some changes here. I'm going to erase this, and again, go back to it in the video if you get stuck and you want to try it again. The more you practice this stuff, the better it'll click with you. But we're going to erase it. We have our vector. I'm gonna push some values, and you notice I'm typing it out all this time because I want it to be repetitive. The more repetitive this stuff is, the better you're going to learn it, I think. So 2, say values.push back 4, values.push back 6. We're going to have those 3. I'm going to show you a different way to loop because what we're going to be doing is we're going to be using values.insert. So we're going to be using the insert function. But the problem with the insert function is that we need to be using an iterator. We can't just define an index and say insert at this particular index. We need to iterate over this vector and then choose where in the iteration process we can actually do the insert. So this is a different kind of loop that we're going to do, but it's not going to be too complicated. So we're going to say for. We're going to use an iterator instead of an integer. So we need to specify what kind of iterator it's going to be. So in this case, it's going to be a vector iterator. The iterator is going to be of type int, and we're going to use : iterator. So that's our iterator. We're going to say it, which is going to be the value that we're going to be using for each iteration. And we're going to start it at values.begin. So this is the start of our vector. This is the first iteration. And this would be similar to saying I equals 0. Then we're going to say, you know what, this iterator is going to continue for as long as the iterator is not equal to the values.end. So the end of the vector. So this is the ending iteration. And we're going to increase the iterator by 1 every time, 1 iteration. So let's go ahead and just print it out first to see where we stand. But we're going to say cout. We're going to say pointer it and L. And it should print out 2, 4, and 6. So it did. It printed out 2, 4, and 6 for us. Now this is where we're actually going to do our insert. So what we want to do is we're going to do a condition statement. So we're going to do an if statement. We're going to say if that iterator value is equal to 4. And we already know that 4 is the middle number in our vector right now. So we basically want it to insert after 4. So it should be 2, 4, whatever our new value is going to be, and then 6. That's our goal. So we're going to do our if statement, and we're going to say values. We're going to say insert. We're going to say iterator plus 1. So the next spot in the iterator. And we're going to say 7. Now, we can't let our iterator continue to run after this because we've now made some changes to our vector. So our iterator it's not going to be in sync anymore. So what we kind of want to do is we want to break out of this loop. So break will terminate our if statement, and it'll terminate the loop, and it'll continue on to whatever happens on line 17. So on line 17, we're actually going to do another loop. Now I could do another iterator loop, a new iterator loop, but in this case I'm just going to do a standard integer loop here. So I'm going to say I less than values.size, and size should have changed since our insert has happened. I++, and we're going to say cout values I and L. So I'm going to save it. So let's go ahead and run it. I'm going to say run task. And you can see that it says 2, 4, 7, and 6. So it worked as anticipated. Now, if I just said iterator and not iterator plus 1, it'll actually insert it before the 4. So we can try it. I remove the plus 1. I'm going to say run task. And it inserted the 7 before the 4. So you can see where that is interesting here. Now let's go ahead and, well, what if we wanted to, instead of insert a value at a particular index in that vector, maybe we want to remove a number. So let's say we wanted to remove the 4, which is the middle number. Instead of the insert, we can say erase. So I'm going to say IT. And I'm actually going to say IT plus 1. So because remember, it's going to try to remove the value before the 4. So we want the 4. So let's try to run it again. Say run task. Oh, it actually removed the 6. Sorry, I gave wrong information. So in this case, it'll actually remove the correct index. So by saying iterator plus 1, it removed the 1 on the end, which in this case, let's go ahead and remove the 1 in the middle. So this time it removed the 4, which is the middle number, which is the current one that's in our iteration. So not so bad. What we could also do if we really wanted to remove the 6, I believe there's a pop function. So instead of saying iterator and then doing all of this loop stuff in order to just remove the ending value, it might actually be easier just to do a pop. And I think it has. We'll try it. We should have values dot pop. Whoops, pop back. So what the pop back says, or at least it should work. Let's run it before I get ahead of myself here. So I'm going to say run task. It said 2 and 4. So what it's actually doing is actually just removing the value at the end of the vector. So kind of like push back, it's pop back. So it's popping it off. So you have options when it comes to using your vectors. Again, this is all stuff that's probably a lot more complicated than just using a standard array. But again, in C++ of all the languages, you probably want to stick with vector because arrays, while they're pretty consistent and universal between every programming language, they're just a little more complicated to use in C++. Let's go ahead and see another example here. Let's go ahead and wipe this out. Let's go ahead and change a few things. So we're going to say vector int. We're going to say values like we've done so far. We're going to say values dot push back 2, values dot push back 4, and then values dot push back 6. This time around, we're gonna resize some things. So if I were to print this out, let's go ahead and print this out. We're gonna use an iterator this time. We're gonna print out what we have, and then we're gonna resize this vector manually rather than letting it expand automatically. So we're gonna say for vector. We're gonna use int. Again, this is an iterator rather than the alternative, just an integer-based for loop. We're gonna say iterator it equals values dot begin. Iterator. Well, it's not equal to values dot end, and then we're just going to increase it by 1. So we're going to see out iterator end L. Let's just run it, see where we stand. So it printed out 2, 4, and 6. Let's expand it. Let's resize this vector. So for example, let's see what happens when I do this. I'm going to say values 5 equals 10. So in theory, I have 3 in my vector right now. If I wanted to skip to 5, well, in theory, it probably doesn't exist. Let's see what happens. Yeah, it didn't add anything. So I ran it, didn't add anything. If we wanted to be able to manipulate a particular index in that vector, we have to make sure that it's properly sized. So let's go ahead and resize it. So we're going to say values.resize, and I'm just going to say that there's going to be 10 elements in this vector. So I'm going to save it. Now it should work because 5 should exist in that 10. So let's go ahead and run it. So I'm going to say run task. And you'll notice that it worked this time. So it said 2, 4, and 6. And then 10 is in the middle. Everything else is going to be a 0. You notice that in regular array, when I try to do something like this, we just had a lot of random integer values, negative or positive. But in a vector, it's a little different. It just initializes every in this case, integer in that vector as 0. Resize was kind of the example that I was shooting for here. So that way we can go ahead and change a particular index. So that's kind of all I wanted to demonstrate when it comes to arrays and vectors. So the focus here is arrays and being able to store multiple elements in a particular variable. But because we're using C++, vectors is definitely the preferred way. If you're using JavaScript or the Go programming language or Java or whatever it may be, you don't have to jump through as many hoops. But this is a back to the basics C++ tutorial. So it's just to get you familiar with arrays and in this case vectors, because the more you see them, the easier you're going to have of a time when it comes to you're learning whatever programming languages you're learning, or your computer science class or whatever it may be. And again, I'm definitely not a professional at C++, but I do use other programming languages daily, and that includes using arrays.